All right, this is Grade 3, Module 5, Lesson 16. And in this lesson, students are going to start placing whole number fractions and fractions between whole numbers on the number line. What does that mean? What that means is basically students are going to start placing fractions on the number line that are larger than 1. That's really all this means. So an example of what we're talking about, let's get this out of the way, is like if we were to consider starting at 0 and moving up to 1 and then 2 and then 3, and if we wanted to cut this into fourths, let's say. Okay, so I would cut this into fourths. So this whole number, this one whole interval has been cut into fourths, right? 1, 2, 3, 4. And then we can cut this into fourths. And you can see 1, 2, 3, 4. All right, and then we'll cut this into fourths. All right, and we could keep going forever. Now the idea is, teachers, what we want students to see is this beautiful, beautiful pattern. In this case, we're going to start with 0 fourths. And then when we go, we're going to get 1 fourth, 2 fourths, 3 fourths, 4 fourths. Now I'm going to put a box right there because that's important. And then 5 fourths, 6 fourths, 7 fourths, and then 8 fourths, and I'm going to put a box around that. And then we get 9 fourths, 10 fourths, 11 fourths, and then of course 12 fourths, and I'm going to put a box around that. And what we want students, and you know what, I really should also put a box right here. Good. So now we want students to recognize this beautiful, beautiful pattern of what kinds of fractions happen at the whole number intervals. So let's look at the numerator. Obviously the denominator is always 4. But then the numerator, here it's 4, then it's 8, and then it's 12. So teachers, you want to take a moment before you move on. Make sure students understand that relationship between the fraction and the whole number. And when they have a particular denominator, how can they identify what the numerators are going to be for each of these whole numbers, right? And we're going to just kind of practice that, but some of your students may need a little bit more explicit instruction on that. Let's get going. So we're going to estimate our partitions. We're going to draw our fractions as best as we can using estimation. We don't need to use a ruler. And then we're going to label the wholes as fractions and box them, just like I previously showed you. And here is the example that they gave us. It says that it's thirds. So each of these intervals has been cut into 3. Each whole number has been cut into thirds, 3 intervals. And then they've identified the fractions. So let's do that down here. So we have fourths. So that means the interval from 2 to 3 is going to be cut into 4 equal-sized pieces. And the interval from 3 to 4 is also going to be cut into 4 equal-sized pieces. And then we need to label our fractions. So if our fractions are fourths, that means we know the denominator is going to be 4. So what is our numerator going to be so that it equals 2 wholes? So what is our fraction? How many fourths equals 2? And the answer is 8 fourths. And teachers, you might have to let students kind of let that soak in. Talk about the patterns. How do they know? Some examples might be, 4 times 2 is 8. Therefore, it's 2. Another way to think of it is 8 divided by 4 is 2. That's another way to think of it. There's a variety of ways, but let the students talk about it. Now we can label. So we've got 9 fourths, 10 fourths, 11 fourths. Here's 12 fourths, so we're going to label it, or box it. And sure enough, 12 divided by 4 is 3, so that's perfect. And then we can keep going. 13 fourths, 14 fourths, 15 fourths, and finally 16 fourths. And there is our whole number. So there's and we can check it. 16 divided by 4 is 4. Bam. So there you go. So there is that example. One more example. But I included this one because I thought this was tricky. It says we're supposed to cut this into fifths, but we're not going to cut this into 5 equal pieces because really, here's 6, here's 9. So we need to put in 7 and 8. So we're going to begin by estimating where 7 and 8 would go. Now we're ready to cut this line into fifths. So the interval from 6 to 7 needs to be cut into 5 pieces. 1, 2, 3, 4, 5. And then the interval from 7 to 8 needs to be cut into 5 pieces. 1, 2, 3, 4, 5. And teachers, you can imagine this. Your students are going to be all over the map in terms of how equal are these intervals going to be. Just give them practice. The more practice they have, the better. It's okay. They don't need rulers. They don't need to be perfect. We're just going to give them repeated practice on how to cut these intervals into whatever number of pieces it tells us to. All right, so I've cut all of our whole number intervals into fifths. Here's a whole number interval cut into fifths, whole number cut into fifths. And now we're going to label. So if we have a denominator of 5, because it says so right here, and we need to indicate 6 wholes. So what kind of fraction, how many fifths equals 6? And the answer is 30 fifths. And we're going to put a box right there. And then we're going to label 31 fifths, 32 fifths, 33 fifths, 34 fifths, and then here is 35 fifths. Now I'm gonna skip for the sake of time a little bit. What would, if 6 is 30 fifths, 7 is 35 fifths, what would 8 be? 8 would be 40 fifths. And I'll put a box right there because we can see it. Here's 35 fifths, so 36 fifths, 37 fifths, 38 fifths, 39 fifths, 40 fifths. And then what would 9 be? 45 fifths. And there you have it. And our last example for this video, it says partition each whole number into sixths. So there's our fraction. Label each fraction, count up as you go, box the fractions that are located at the same points as whole numbers. So this is basically what we've been doing all along. And we're going to begin by cutting each whole number, each interval, into sixths. All right, now I know that 6 is 2 times 3. So teachers, a little bit of a shortcut to help your kids cut something into sixths. First, cut the interval into 2 pieces, and then cut each of those into 3 pieces. So we're going to cut this guy into 3 pieces, 1, 2, 3, and then we're going to cut this guy into 3 pieces, 1, 2, 3, and that is a nice, cool shortcut for cutting something into sixths. Let's do the same thing over here. First, we're going to cut it into half, into 2 pieces. 1, 2. Now we're going to cut each of those halves into 3 pieces. 1, 2, 3, 1, 2, 3, and there you go. So it's a nice little trick for teaching students how to cut something into sixths. And now we're going to label. Well, we know the denominator is going to be 6, because it says so, sixths. But how many sixths equals 3? How many sixths equals 3? The answer is 18 sixths. So then this is 19 sixths, 20 sixths, 21 sixths. Let me just put that one there. And then 22 sixths, 23 sixths, 24 sixths. So there is 24/6. And sure enough, 24 divided by 6 is 4. Nice little trick. So that's 24. So we've got 25/6, 26/6, 27/6. So I don't lose my place. Let's put that there. And then we have 28/6, 29/6, and then lastly, here it is, 30/6. And sure enough, 30 divided by 6 is 5. And that is the beautiful art of placing fractions on a number line that are larger than one whole. And that wraps up Grade 3, Module 5, Lesson 16.